All right, well, hey guys, we're going to start this new chapter today, chapter 9. It's all about linear equalities or inequalities. And we want to take a look at this unit from the perspective that there are two things that you'll need to know specifically when you get to high school, and that's just the understanding of what an inequality is, and you will need to know how to identify them on graphs, and you'll need to know how to be able to solve them correctly. And there's some interesting things that go along with that. So it's actually not that hard of a unit. And so if you just keep up, this should be pretty simple. The first thing that we're going to look at here is the word inequality. And what that means is that you actually have greater than or less than signs in between your two variables. And so the most important thing about this unit is language or lingo, the English language, meaning that you have to interpret and understand what means greater than and what means less than. So if we're going to look at this one right here, if we look back to when we were little, how I always explain it is when the open face there, the open little, like inequality sign is open to the A, it means that it's greater than. It's like the crocodile. Do you guys remember this? So it's like the crocodile, and he always wants to eat the bigger number. So what it would mean is that A in this case is greater than B. Okay, so the crocodile always opens up to the bigger number, okay? So just remember that, okay? So it's a little crocodile, and you want to know that it's open up. This next one here, when it's pointing at the letter, okay, so when that little point is pointing at the A, it means that A is less than B. So it means that it's a smaller number, okay? So A would be smaller. So if we look at these two, I'm just going to look at the first one right here. I'm just going to put a 1 and a 2. So when we look at 1, we saw that A is greater than B. And so what that means is that if we would have A could equal 6 and B could equal 2. And because A is 6, it's bigger than 2. That's why we use this sign. If I do an example for number 2, where it said that A is less than B, then you would have a representation like A could equal 3 and B could equal 7. And because A, see how it's smaller, 3 is smaller, that's why we use this here. So pretty simple. Just make sure that you remember that the crocodile is eating the bigger number right here, and that when it's pointing at the letter, it means less than. Cool beans. So that's really super important in this whole unit. So just make sure you know the language. There's a new sort of sign that we're going to use here, and that's when it's like there's a greater than sign here, and there's a line underneath, and that means greater than or equal to. So that line is just basically half an equal sign. So what that means is that if we look at this example here, A is greater than or equal to B. So let's just pretend that we had A being 6 and B being 6. So this could be, so A could be 6, 7, 8, or 9 in this particular case. So A is greater than, that's a brutal sign. A is greater than or equal to B. So do you see how A here could be 6 and B is 6? So it could be equal to, that's why we put this little line underneath. But A could also be 7, 8, 9, or 10, because A can also be, and I made the wrong sign. This is the sign we're supposed to be using. Okay, cool. So 6, 7, 8, or 9. Cool. So A could be 6 and B could be 6, right? But A could also be 7, 8, or 9 because it's bigger. The crocodile's eating it. So this number could be bigger than B. So that's what that means. When the sign is pointing, when it's like pointing right at the A and it has an equal then sign underneath, it means less than or equal to B. So that means that A's got to be smaller than, or it could be equal to B by using this line. If you get an equal sign that has a cross right through it, it means it's just not equal to B. So you could have something like A is not equal to B, and you could have A equaling 4 and B equaling 6, and you'll notice that these two numbers are not equal, so we could use this sign if it was asking for that sign specifically. Normally in an inequality we don't use this sign, but we just need to understand what it means. We're pretty much using all of these signs right here, greater than or equal to. So we're going to work with an example of what you're going to be doing over the next few pages here, and really just decoding what everything says. So the example is Bob earns an overtime pay when he works more than. So the first thing I want you to do is always understand that the language is important. More than means greater than. Okay, and so you want to basically highlight that. You want to know that it means, that's what that means, because it's the whole part of it. More than 40 hours a week. Okay, give 4 possible values, so that means 4 possible numbers, right? That would result in overtime pay. So we looked here and we said that he gets overtime when he works more than 40 hours. Okay, so let's give 4 answers that could work. Anything over 40 hours works, guys. So yeah, he'll get paid overtime for 41 hours. He'll get paid overtime for 50 hours. He'll get paid overtime for working 40.5 hours because he'll get half an hour overtime pay. He'll get paid for working 40.25 hours, which is a quarter of an hour. So he'd still get paid for that. And anything over 40, so like 45 or 60, whatever. So anything over more than 40 hours. Super important lingo that we have to notice. Okay, the next thing that they're going to ask you to do is verbally express the amount of time that qualifies for overtime. So what you've got to do is you've literally got to, this verbally right here means write a sentence. So what you would do is you would literally write this down, the amount of time that qualifies him. So, so if Bob works greater than or more than, so I'm just going to write that down there, or more than 40 hours, he qualifies for overtime. Okay, so that's verbally writing a sentence. So that's what that means. You just write a sentence. Here's where things get a little more technical, and what you're going to see throughout this unit and also throughout just the next few years as you get through high school here is representing inequalities graphically, okay? So super easy concept, but you have to memorize it. There are 2 types of circles we use on line graphs. They are open circles and closed circles. So we're going to use, we just got to take a look at this, and an open circle, okay, so everyone's looking here. An open circle means that if this value is, which is 40, is not possible. Okay, so an open circle means that this value of 40 is not possible. So what you noticed here is that I made a circle over the number 40 because Bob has to work more than 40 hours to get paid overtime. So if he worked 40 hours and he got paid for overtime, I would color that circle in, but he doesn't get paid for the 40, so I'm leaving it open. Then what you do is you need to you need to draw this little arrow pointing at which way the graph would go if he got paid more, if he got paid overtime for more than 40 hours. So you'll notice that my graph is pointing towards the 40, 50, 60, 70 because it's pointing in the greater than direction. I kind of want to show you something here, which I usually say and show in the classroom, and we haven't gotten here yet, but we know that if Bob works more than, which is the greater than sign, which I wrote right there, 40 hours, then that's what would result in an inequality. I just want to point out here that see the direction that this little thing is pointing? It's pointing this way. Your line actually points the same direction. So check this out. This line, this sign right here, okay, same direction, same direction. So it's just kind of a cheat if that's something that you have trouble with. So closed circles on the graph, which is the next line here, closed circles means that the value can be possible. So the next type of graph is if we had a line graph here and you found the spot and you colored in the dot like this, and then you made your arrow go whatever direction you needed to go. Now, Bob's graph doesn't have a closed circle because the value is not possible. If he works 40 hours, he doesn't get paid overtime. So that's why we did not, in our example, like up here, color in the circle. But let's say that if he did work 40 hours and he got paid, we would color in the circle because that would include the number 40. So a circle means that you're including the value, and no circle means you're not including the value, but it could be anything after that. So here it is, express the inequality algebraically. So this way is the way that we're used to writing it. And I have already done this. So we know that if Bob works greater than, more than 40 hours, so all we have to do is use the inequality, which is the symbol greater than or less than, or greater than and equal to and less than and equal to. So we know that if he works greater than 40 hours, so that's how we represent our inequality algebraically. We just use the sign, the greater than or equal than sign, with a variable here. So his time is greater than 40, t is greater than 40. So this is basically normally how we write things, but if it asks in the textbook to write it algebraically, that's how you do it. And then represent the amount of time that he does not qualify for overtime. All right, so here's the thing, guys. He has to work a 40-hour week. So when you think about that, he has to work the 40th hour. So we have to use the sign that includes 40. And we know that he's not going to get paid overtime if he just works his normal hours, which is less than or equal to 40. So we're going to put that sign in. Remember that the less than sign points at the t, okay, because it's not bigger, and we're going to use the equal than sign. So the algebraic statement for him not qualifying for overtime pay is his time is less than, which is why I use this sign, or equal to 40. Okay, so his time was less than or equal to 40, because he could work 40 hours, but he won't get paid overtime for it. So now we're dealing with this sign that has an equal sign underneath it. So this is where we're going to use our special graphing technique, because I told you that when there's a line underneath here, that means equals. So that means that the value can be 40. Okay, so the value can equal 40. All right, so if we're going to graph that, we need to go to our 40 and put a circle around it. But because it can equal, we're going to fill in the dot. All right, so that's what that dot means. And we notice that the arrow is pointing to the left. So we're going to make our arrow go the same direction, to the left. And so now you can see that if he works 30 or 20 or 10 hours, he'll get paid for overtime. And so that's how you represent a less than or equal to graph here, by filling in a full dot. Up here, we used an open circle on this particular graph because he didn't get paid for that 40th hour. So he can't, he gets paid for anything over 40. So we just leave an open circle for that. Greater than 40 is this graph, okay? Okay, express the inequality shown on the number line algebraically. Remember that algebraically just means that you're using a variable and you're using that greater than or less than sign. So I'm just going to use x because it makes sense. Okay, first cheat that I have is I'm looking at this arrow and which way it's pointing. It's pointing to the right, so I'm going to use that sign. But I'm not done here because I need to decide this dot was colored in, okay? It was shaded in, and when it's colored in and when it's full, it means it can equal that. So I need to put an equal sign there. Now I got to figure out what value that is, so I actually got to kind of decode the graph. It looks like my graph is going up by 5s, or in this case, going down by 5s, and between -10 and -20 is -15. And so this answer reads this: x is greater than or equal to -15, which means that as we move closer to 0, okay, it gets bigger, and as we go past 0, it continues to get bigger, and so that's how we draw the graph. If we look at the next example, we notice that the line is open. This one's harder because the two numbers that it's in between are 2 and 3. So this is an example, you guys, of you actually having to see how many points are in between, or how many hops are in between the two whole numbers. So I'm just going to count how many hops there are from 2 to 3 in this particular graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hops. So that means that we're looking at a decimal out of 10, or a fraction out of 10. So which one did we move to use the circle here? 1, 2, 3, 4. Okay, so, and we're moving up. So 2, this could be 2.4, because there's 10 spots, so that's fine. I could go up to, if there's 10 spots here, this would be 2.10, this would be 2.9, this would be 2.8, if you see what I'm doing. We could also use fractions if we wanted to. So since we know that there's 10 spots between each thing, this would be just 2, and then this one would be 2, the whole number 2 and 1/10. You see and then this would be 2 and 2/10, and this one would be 2 and 3/10, and so this is 2 and 4/10, and that's why, guys, that's why the fraction is 2.4. Okay, so that's how you have to look at the graphs. You can use a fraction if it makes sense and it's harder, it's not a nice out of 10. The only time we can use decimals, but the thing is that decimals work out nicely when we're using it out of 10. So I know that I can write here, just going to erase this now, and we're going to take a look at the graph. We know that it's an open circle. And so we have to actually decode that. So we're going to look at the way that the graph is pointing. It's pointing to the left. I'm going to use the same sign, sorry. And it's not a filled in circle, so I do not put an equal sign underneath it. And I need to remember where that was. We said that that was at 2.4, so I'm going to write that x is less than 2.4. And so we know that back here is going to be 1 and 0, and that's why it's getting smaller. So that's what that means, is that the graph is pointing towards the smaller side. It's getting smaller. It's less than 2.4. So guys, you can actually just pause your tape here, like if you want to, and just take a look at these examples, do them yourself, or you can just watch me do them real quick. What's different about these is that you actually have to draw the number line yourself. And so you have to make sure that you're using correct values in there, make sure that you are mapping it out really well. The top two ones are easy, the bottom two involve fractions, and so you're going to have to do that correctly. And then something you don't have on your sheet is these two examples right here, which will be in your homework, so you'll need to watch that for sure. So don't just kind of end the video and be like, I'm done with it, because you won't know how to do the weird stuff at the end. So I'm just going to go over these real quick, and I'll show you how to do them. So this one says x is greater than or equal to 12. All right, well, that's simple. So I need to choose my number line. So I'm just going to make this like 10, 11, 12, 13, 14, 15, 16, 17. I'm going to go to my 12 value. Because there's an equal sign underneath, I'm going to color in my dot, because that means that it's equal to. I'm going to use this as my direction. It's getting bigger, and so I know that greater than means bigger than 12, and so that would be representative of that graph. The next one here is less than 4, so I'm going to put 5, 4, 3, 2, 1, 0, negative 1, negative 2. I do want those of you that are building graphs to remember that 0, going to the left, so this way, always gets smaller, so your 0's there, and the negative numbers fall to the left, and that the positive numbers are always going to the right. That's always how you have to write a number line. So this is x is less than 4. So I go to my 4. I'm gonna put a circle around it. I notice there's no equal sign, so I do not color it in. I look at the direction that the arrow's pointing. I go ahead and add that to my graph, and I'm finished. The next one is 3.4. So this one, again, similar to what we saw before, I'm going to put 10 hops, not 10 lines, you guys, 10 hops, okay? If you do 10 lines, you'll actually have 11 lines, and the graph will be wrong. So check this out. I'm going to put a 3 here, and I'm going to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, listen, if you had just counted lines, let's count the lines here. I just want to show you how it's different. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you notice how there's 11 lines? You need to count 10 hops to get to an exact amount of spacing that's correct. So this is 3.0 on this side. This is 4.0, sorry, and we're looking for 3.4. So this is 3.1, 3.2, 3.3, and 3.4. It tells me that it's greater than or equal to, which means that because that equal sign is underneath, I put a full circle, and I make my graph go the direction that it's asking me to get bigger. I know that 4 is bigger than 3.4, so I know I've done this correctly. The last one here says x is less than 4 over 10. So remembering as a decimal, you guys, 4 over 10 literally means 0.4. So it's a very small number, and 0.4 is in between the numbers 0 and 1. So I'm going to do the same thing. I'm going to use 0 here and 1 here. And since I know there's 10 hops, 3, 4, 5, 6, 7, 8, 9, 10, then I'm just able to go to the fourth hop. 1, 2, 3, 4. I'm able to put a circle around it. It does not have an equal sign, so I leave it open. I look at the direction. It's getting smaller. I make sure that my graph is pointing towards the smaller section. This would be 0.4, and yeah, 0 is smaller than that, and then down here would be negative 1, so I know for sure that it's smaller, and that's how you graph that. The last thing I want to show you is when there's an x in the middle of two values. This happens a lot in your textbook, and it might totally throw you off if you don't have a clue and you haven't listened to this section. So we need to actually read the x as what it is. So you always are going to start by saying x. Okay, so you're going to always start by saying the letter x. So I'm going to read this part first, okay? I'm going to isolate it. It's broken into two things. If I read it, it says x is less than or equal to 5. Cool. So I'm going to go to 5. I'm going to put a circle with a filled in circle because there's a line underneath it. And I know that the graph is going to go this way because look at this direction points this way. But there's another statement in here. Starting with the x, reading it from the x, you're going to read it backwards. X is greater than, this is greater than 1. So then I'm going to go to number 1 and I'm going to put a circle on it because it does not have an equal then sign. And if it's greater than 1, then 2, 3, 4, or 5 makes sense. So the graph goes this way. Now, guys, look at this. This is you understanding that this statement back here is backwards. The way to debunk some of this, and actually this is the answer here, so just to be clear, there's going to be 2 dots on the line, a line connecting those 2 dots. One of them in this particular case is a full colored in one, and one of them's empty. So if you like, and this is confusing for you, some of my people like to do it like this. They like to be able to rewrite the statement. So if I was to rewrite it, it would be x is greater than 1 and x is less than or equal to 5. I just rewrote the statement that was here, and that makes more sense to me because then I know that I can go to the 1 here and I can put my arrow going this way, and I can go to the 5 here and my arrow can go this way. We're going to look at this one here, this next example. So again, break it into 2. I'll write the 2 down here. X is greater than 2, and x is, I'm doing it backwards, less than 5. Do you notice how I wrote this? When you read it, x is this sign. When you're reading it this way, you're reading it backwards. That means less than, because guys, the inequality is pointing at the x. All right. So I've just rewritten them here. So it makes it a little bit easier for me to decode. So I'm going to go to the 2 value, put a circle around it. I'm going to go to the 5 value and put a circle around it. It doesn't have an equal sign, so they don't get colored in. And then I'm just going to connect the lines in between those two. And that is how you do inequalities when the x is in the middle. Remember that you have to read the back part backwards. Well, not backwards, but you have to kind of start with the x all the time, okay? So that is how you do this whole particular section. Pretty simple. Really all it is you using words, using greater than or equal than, and being able to graph that with dots that are open or closed. That's all of your assignment is today. So hopefully that's good.